So today we're talking about one-to-one functions and their inverses. So we're going to write the inverse of linear, quadratic, rational, and square root functions. Something that you did last year is you did write the inverse of linear functions. And so we're just expanding that skill. And then we're also going to explain the meaning of inverse in real-world problems. Okay, so as you get into higher level math, it's going to be more about explaining, can you explain something well, and not just whether or not you can do it. So I'm going to just teach you some things about explaining and making sure you're good to go on that. So we're going to start with how to find the inverse of a function, and I have written down a little list for you. Okay, so the first thing that you do is you switch your f of x to a y. That step you don't even necessarily have to write down. And then we switch the variables x and y. Do you guys remember doing any of that last year, switching the variables and then solving for the y variable? Okay, so then you solve the equation for y, and then you replace that with the inverse. So we are going to be using this inverse notation. Okay, so we're going to make sure that we're following these steps. And when you're finding the inverse, okay, it's your steps that are going to be important here. So like I said, you can replace it with y. I'm really going to let you start at the second step, but it's y equals 6x minus 8. And then for every inverse, the x and the y are going to switch places. So we have x equals 6y minus 8. And then we're using our rules of algebra to help us solve. Okay, so we're going to add 8 to both sides. And then we're going to divide by 6. Now this is a linear function. Anytime you have a linear function, it needs to be in the form y equals mx plus b. So as you're dividing these, as you're dividing each one by 6, we're going to have to reduce. And if you have that in slope-intercept form, okay, what we're going to do is we're going to simplify. So we want it to be inverse notation. So if it's in the form y equals mx plus b, we like to see the slope in front. So if there's no number on top, it's going to be 1 over 6. And then 8 over 6 reduces to what? 4/3. Okay, so you always want inverse notation, and then anytime it's linear, you're going to put it in slope-intercept form. Okay, and then like I said, we are going to expand this year. We're not just doing linear functions. We're going to do different types of functions. So for b, we're going to do f of x equals x to the 7th minus 7 divided by 6. All right, and then we know our f of x is going to be a y, so I'm fine if when you're doing this, if you want to start by just doing x equals y to the 7th minus 7 equals 6, instead of writing out the y equals step, that's okay. And then now we're trying to get the y by itself. So what do you think we have to do first? Yep. So then to show that, we're going to put that in parentheses. Those are going to make 1, which is why they cancel. Okay, and then I want you to try to do the next couple steps. It's okay if you need help with the second one, but think about how you're going to get y by itself here. All right, so first step, Brennan, what'd you do?
I added 7.
Good. Add a 7 to both sides. And then, Nolan, what'd you do for the next step?
7 through.
Yep. Good. So remember, if this was a 2, you take the square root. So because it's a 7, we're going to take the 7th root. Okay, and then our last step is just to write it in that inverse function notation. So this is pronounced F inverse, and it's the 7th root of 6x plus 7. All right, nice job. Okay, for C, we're going to have f of x equals the square root of x minus 6. Okay, so why don't you do your first couple steps there? And I'll have you guys help me. All right, and then Micah, can you tell me what you did first for this one? Good, so we're going to square both sides, so we're just showing that step. So then we have x squared equals y minus 6. Whenever you square the square root, they undo one another. Then to get y by itself, we just have to add 6. So we have x squared plus 6, and if you want to write that in function notation, there you are. Okay, now the other type that we're going to talk about today are rational functions, okay? So these are going to have a few extra steps here. Okay, so why don't you guys start with the first step, and then we'll talk about some strategies, what we're thinking, because this one is going to be a little bit different. Why is this one different? Yeah, you have 2 variables, okay? What is your guys' first instinct to solving it? Okay, yeah, so we do want to get rid of the fraction, so we are going to multiply both sides by the denominator. So let's see where that takes us. Okay, so here we're going to cancel, so we'll get 4y minus 2. Okay, and then on this side, you are going to have to distribute, okay? So we're going to distribute the x. So if you multiply 3y by x, we write that as 3xy. Okay, and then do we have any ideas with this step? We are trying to solve for y, right? Okay, so we can add the 2 over here. What's the goal? Get y by itself, but then we have this y here and this y here. Okay, if you divide it by y, let's see what happens. So if you divide everything by y, you don't write this part down. Let's investigate. Okay, if you do that, you get 3x, but what does that become? X over y, and then that would be 4 minus 2 over y. So I really haven't gotten rid of a y. I really just placed it into 2 other different places, so that's a good thing to try. Okay, and we could add 2, but then I have the 3xy plus x plus 2. So even if you did that and divided by 4, the problem is you still have a y here. Okay, so just like when we have like terms, we have to get them all on one side. We're going to want all the y terms on one side. All right, and so let's move all of the y terms together. And then if it doesn't have a y in it, let's move that to the other side. Can we do that in one step, or would you rather do it in 2? Okay. So if I move the 4y over, I'm going to move the x over here, and I'm just going to regroup these. So on this side now, I have this. I have 3xy minus 4y. Okay, on this side, I'm left with these two things. So I'm going to write it as negative x minus 2. What can we do on this side? Yeah, you can factor out the y, right? And look, the 2 become 1. So if you take out the y, this becomes 3x. Negative 4y divided by y is negative 4. So this is looking promising because now what's the only step I have left to do? Yup, you can divide it now. Now it's a factor. Okay, so then you're left with y, so I'm going to write it as my inverse. Okay, now sometimes you might have an equivalent answer. Like I chose to move all of my y's to this side. Really, you can move all your y's to the other side. Okay, you would just have opposites, which is fine too. Okay, so we multiplied by the denominator, and then if you want to write a little note here, the goal is to get all y terms on one side. And why do we do that? So that we can factor. Okay, so once you can factor out that y, that's all you have left. Because you have the one y and you can solve for that one variable. Okay, so this one is similar. Why don't you guys give this one a try? I'll come around and help you. So you have f of x equals 3x over x minus 2. Okay, so it looks like we got the first two steps down. Like we know to multiply by the denominator. We're doing a nice job at distributing. Okay, and then once we get here, it really doesn't matter what side you move the y's to. Generally, I will move them to this side so that it's not like backwards. So if I move the 3y over, I'm subtracting it. So if I did xy, minus 3y, okay, then I would add my 2x to this side. And it's okay if you didn't do it like this. I'm going to go over both answers. Okay, then you can factor out your y. So if you factor out your y, you have x minus 3 equals 2x, and then we'll just divide by the x minus 3. And then we just want to put it in inverse notation. Okay, so I know I have like that extra step in there. It's okay if you go right from here to here. Okay. Now, did some of you move this to the other side just because then you'd have, you wouldn't have to move the 2x over? Okay, so if so, when you subtract the xy, you have negative 2x equals 3y minus xy. So you'd have 3 minus x on the top, and you would divide both sides by 3 minus x. Okay, and you can leave your answer as negative 2x over 3 minus x. Okay, I would not mark that incorrect. You can also think of this as negative x plus 3. So if you factor out the negative there, you see how a negative over a negative is going to result in a positive? You could get the same thing that I did, okay, just by doing the negatives. Okay, so like I said, this is an acceptable equivalent answer as well. All right. Good job. So now we are going to talk about inverses and then what they mean in context. Okay, so the amount of a commodity that is sold is called the demand for the commodity. The demand for a certain commodity is a function of the price given by this equation. Okay, so when you have this D of P, okay, it's asking you to find the inverse and then what does that represent? Okay, so we're going to find the inverse and then we're going to explain what it represents. So one thing I always like to go back and identify is what the variables represent. So we know the demand is the D. And it says the certain commodity is a function of the price. Okay, so for this equation here, the D of P, okay, for function D, the input is the price, which you can see in your equation, right? P is the input, the output is the demand. Okay, so then what we're going to do when we find the inverse, okay, is we are going to solve for the other variable. Now, when you have a real-world problem, you do not switch the variables, okay? It's because they're attached to a certain quantity, they each mean something. So when you find the inverse, and we're writing this down because this is usually something that students forget when it comes time to the test. So I want you to have something, so when you're reviewing for your test, when you're doing your homework, you have this written down. So when you find the inverse, okay, for a real world problem, okay, you do not switch the variables. Okay, so when you find the inverse for a real world problem, you do not switch the variables. Okay, what you do have to do is solve for the current input value. Okay, so in this case, our current input is P. right? So if you have D of P equal to negative 3P plus 150, okay, they do shorten it up. So like instead of D of P, they'll just write it as D, and that's fine. Okay, so we would subtract 150 from both sides. And then divide by negative 3. Okay, so we're solving that equation for P. So when you do that, remember this is a linear function. So one way that you can write that is negative 1/3 D. And then what's negative 150 divided by negative 3? Positive 50. Okay, and then another way that you can write that instead of just the P equals is you can write the D inverse. Okay, so when they're asking you to find the inverse of D, this is what it is. Okay, so instead of your value of P, you can write it as D inverse. Okay, so whenever you're finding the inverse, the input and the output are going to switch. Okay, so for the inverse, the input is the demand, and the output is the price. Right, so anytime you are finding the inverse, the input and output switch. Okay, when finding the inverse, the input and the output are going to switch. Okay, so notice here it says the demand D for a certain commodity is a function of the price. Okay, so now our function is going to be of the demand. So we're going to say that the inverse represents the price P that is associated with the demand D where the price is a function of demand. And I just put an extra letter there. Okay, so this is your explanation. So the inverse represents the price P that is associated with the demand D, where the price is a function of demand. Okay, so you want to make sure that you're labeling what each one of these represents. Okay, so we know that your P value is going to be the price in dollars. Okay, and then the demand is going to be the units of a commodity. So this is going to help us with step B. Okay, so the demand is the units of a commodity. It says the amount of a commodity that is sold. Okay, and then the price, we measure the price in dollars. Okay, so when it asks you to find the inverse of 30, you are going to use your new equation. Okay, so you're going to plug 30 in for D. Okay, also remember that this is the same thing as your value of P. So when you're talking about what your answer represents, we are going to reference that price. Okay, so what is negative 1/3 multiplied by 30? Negative 10. Negative 10 plus 50, 40. Okay, so when you have the inverse of 30 equal to 40, we have to explain what this represents in the context. Okay, so your answer should include both the input and the output. So just include the input and the output values. Okay, so the reason why I put the P here is so you remember that P is going to be the price. Okay, what is the 30 representing? Yep, so the demand is going to be that units of the commodity. So we can say when the demand is 30 units, and again, up here, we did write down the input is the demand. So you can see that 30 is the input, right? So when the demand is 30 units, the price per unit is $40. Okay, and make sure that you do include your units in your answer. Okay, questions for me on that part?
I'm just confused as to where you got the negative 1/3.
Oh, so for here it was D over negative 3.
Oh,
Yeah, so just like if you had X over negative 3. Yeah. Yeah. And the only reason why I wrote it like that is because it is linear. And so we can put it in the slope-intercept form. Okay, and then for part C, we're going to have a different narrative, okay? So it's going to be very similar, but now the demand D for a certain commodity, it says where D is measured in hundreds. So that's going to be different, where D is measured in hundreds. Okay, that is a function of the price given by, and it's the same equation that we did before. Okay, so it's the same thing we had. We are just going to explain what your answer in part B represents. Okay, so for this situation, you have the same exact values. It's just when you have something that's measured in hundreds, sometimes we forget how to convert that. So for this situation, your output is still going to be the inverse of 30 is equal to 40. Okay, so that means the input for your calculation stays the same. So sometimes in order to keep an equation simplified, they will just tell you that the unit is measured in hundreds. Okay, and then when you're explaining what that means, you just have to incorporate that into your answer. Okay, so if D is measured in hundreds, then all we have to do is take the value of D and we're going to convert it. Okay, now remember how P was the 40? So that means the D value is what? What's the D value? If the P is 40, what's the D? Okay, so if it's 30, but it's measured in hundreds,
300.
you just have to multiply it by 100. And it's 30, right? So it'll be 3,000. So if it's measured in hundreds, to convert, you multiply by 100. If it's measured in thousands, you're going to multiply by thousands. It's measured in millions, you're going to multiply by a million. Okay, so same thing. So when the demand is, and in this case, it would be 3,000 units, the price per unit is, now, did anything change with the price? Did it say P was measured in hundreds or anything like that? No. So if it doesn't specify, then that is going to stay the same. So when the demand is 3,000 units, the price per unit would be $40. Okay, so then for D, it says now let's consider that is measured in hundreds, so the same as before, while the price is measured in thousands. Okay, so all we have to do is take our value of the price and we have to multiply it by what? 1,000. So again, notice your input and your output do not change. Okay, so if the D is measured in hundreds, you multiply by 100. I know we just did that. Okay, and then your price was 40, but if that's measured in thousands, 40,000. Okay, so then our explanation would be when the demand is 3,000 units, the price per unit is $40,000. Okay, so each one of these situations is different. Okay, so for something like this, we could be talking about cars, right? Something that would cost around $40,000. Okay. So I just want you to see that depending on what they tell you, what it is measured in, you're going to have to adjust that. Okay, so make sure that you're practicing the explanations for those. And then while you guys are starting on this, if you come over and go over some of your homework problems. Okay, so less than 10 problems. I just wrote them out one by one. Okay, so you have a good chunk of time. Start that.